Okay, so this is for people that are absent, but as well as just anybody that is maybe just not 100% clear on a few topics. So here's a quick lesson. It's really the same one I did in class, but it's just about product and quotient rule. And again, I'm not going to go over the proof of product or quotient rule here. We're just going to go over using that. So here we go. This is a quick lesson on product and quotient rule. So for starters, let's just remember what that is. So if we are going to take the derivative of, let's say, so remember d dx is the operator that says, go take the derivative of the argument that's on the inside. So the derivative of f of x times g of x is f prime g plus g prime f. Now, I usually, when I say it and I articulate it, I don't usually say the of x. I just say f prime g plus g prime f. And I make sure that I do that very, very carefully on that. So the first one that is a product rule would be this one right here. I would consider this first piece f, this second piece right here g. So at least in the opening stages of learning this material, I would love to see you make a little note to yourself to say, I want to do f prime g plus g prime f. F prime, again, simple power rule. The derivative of 5x cubed is 15x squared. G, of course, is the cosine. F prime g doesn't change that second piece. But then we have to do plus g prime f. And now the f is not going to change, but the derivative of the second piece will, and the derivative of cosine is negative sine. So this is a good answer. It is pretty typical, though, for analysis of these at a later time to do whatever factoring we can. So this is a valid answer, but an alternative answer would be, let's say we took out a 5 and an x squared out of these both because they both have a 5 and they both have at least x squared. And that would leave me with 3 cosine minus, I guess, just x, huh? And we would be done with that particular question. Now, the quotient rule says we're going to go ahead and take the derivative of the quotient of f over g. And what we did in class is we talked about this little statement that was a low, which is d low is g of x, d high, so gf prime, so it's low d high minus high d low, and we square the bottom. And we can write it as g of x squared, or you could say g squared of x because that's the same thing. Low d high minus high d low over the square of what's below. We're good to go. So that's my story right here. So I'll go through 1 and 3, and then we'll get to these harder ones here in a second. But here we go. So y prime, or the derivative of that, here is my low. D high would be 4 minus high d low, which of course is 2x, and then we square what's below. Now, it is usually considered proper etiquette to simplify things to the best of your ability. If you look right here, we've got a 4x squared, and if you look over here, we've got a negative 8x squared, so I'd have negative 4x squared on top, because notice 4x squared here, negative 8x squared there. I've got here, there's a 2, so that's a 4x minus 4 all over x squared minus 1 quantity squared. So that would be my derivative of this particular function. Now, this is nice because we're literally just looking at the derivative of a cotangent here, and it's useful to do. So my derivative of this function, if we were calling this whole thing f, would be low, d high, because remember the derivative of a cosine is negative sine, minus high, d low, which again the derivative of the sine is the cosine, over the square of what's below. Well, What happened right here is we have a negative on both of these. So I'm going to factor that out, and I've got sine squared here, and I've got plus cosine squared here because they were both negative. Well, that just became -1. And so the smarter way of saying that would be negative cosecant squared, and that would end that particular story. Now, what happens some of the times is you get yourself into a little bit of a pickle. Number 4 is a little bit more of a challenging problem because although this is a product rule, there's also very obviously a little bit of a quotient in there too. So I have something times something else, but there's also a division. So if we were thinking about this as being one of the pieces and this as being another piece, if we were to do f prime g plus g prime f, we have some work to do. Because when I go to find f prime, this piece right here is a quotient. So in order to find f prime, I have to use the quotient rule on that piece. So I have a low, d high would be 1. The derivative of x is 1. Minus high d low, which is 1 over the square of what's below. So all of this right here, all of this is f prime. But I still have g, which is the sine, plus g prime. Now, the derivative of sine, of course, is cosine of x times the other one, which is x over x plus 1. Now, that being stated, that looks kind of like honestly horrible, but we can probably simplify it a little teeny bit here in that you have x plus 1 on top right here, but then minus x here. So all of this x plus 1 minus x just became 1. Interesting. So we have 1 over x plus 1 squared sine plus cosine times x over x plus 1. And like I said in the other ones, a lot of times you look for what they have in common. These both clearly have an x plus 1 in common, so we might choose to rewrite it as x plus 1 like this, and this would be the sine over x plus 1 because there's 2 of those x plus 1s and I just took out one of them. And over here, when we took out the x plus 1, all that's going to be left would be the x cosine x. And we usually would choose to put the x in front of that because otherwise somebody might accidentally think that would be the cosine of x times x, which would be cosine of x squared. We usually pull that to the front just so that there would not be any confusion. Now, the last one I'm going to do on a little bit of a sticky note because I didn't give myself really sufficient room, at least not in a way that I like to write. So I'm going to go ahead and look at this last one. And I don't really know that it's going to need to be that long, but let's see what happens. So if I'm looking for the derivative of x secant x, the first thing I'm going to do is I'm going to choose to rewrite that in what I feel like is a more intelligent way. I'm going to rewrite it as x over the cosine of x. Now, so we'll see. So I'm going to apply this using the quotient rule. So let's see. We have a low, and of course the d high is 1. So I don't need to really write times 1 because it doesn't do anything. Low d high minus high d low. Now the derivative, of course, is cosine is negative sine over the square of what's below. We got it. Now, if we wanted to, we could leave it like this because I really don't see anything particularly wrong with it. But again, a cosine over a cosine squared would be 1 over the cosine, which this particular piece would be a secant. And then if you look at it this way, a sine over a cosine is a tangent, and 1 over the cosine is a secant. And so we could write it that way. But we could also look at it in the other way, which I'm going to put over here, x secant x. If we think of that as f and that as g, we need to go ahead and take the derivative of f prime g plus g prime f. And so the derivative, of course, of the first is 1 times the second, which is secant x, plus the derivative of the second times the first. So I need to put g prime here. And this is one of those memorized facts that I would like you to have memorized over time, is that the derivative of the secant is secant tangent. And you'll notice that I did get exactly the same thing, although I wrote it in a slightly different order over here, but it's the same stuff, okay? So you can see if you have memorized what the secant is, it saved you a little bit of time in my simplification step. Now, what'll happen, just so you guys know, is that we can take derivatives multiple times. These are higher derivatives, so we'll just be clear on this one. Is that if you have a position function, like what is your, like where are you from your starting place? How far are you away from that? Your velocity is your rate of change of your position. So if you took the derivative with respect to time, now again, we haven't really talked about what that means with respect to, but instead of using x as our variable, we're using t as our variable. So the derivative of position is velocity. The derivative of velocity is acceleration. But since the derivative of velocity is acceleration and velocity is the derivative of position, try to keep all that straight. That means you had to take one derivative to get to velocity. You had to take another derivative, or in other words, a double derivative or a second derivative to get there. So what has happened is over the years, calculus has come up with all sorts of ways to say the same thing. So when you look at a first derivative, let me focus this in a little bit more, we could call it y prime. That's a shorthand. We could call it f prime of x, or we could call it dy dx, or we could say operate with a derivative on the function f. A second derivative is y double prime, or f double prime, and then you say d squared y dx squared. Now that's a little bit weird, the position of that, but what you're really doing is you're taking the derivative of dy dx, which would be the second one. So if you kind of follow how the math kind of looks on there, it kind of makes sense how that looks like d squared y, and the dx is all getting squared. That's not really what it means, but it does work. And if you notice, the operator says d squared dx squared, means take the second derivative. And then, of course, we can go down with triple primes and quadruple primes and all the way down into this. And you can have all these varied derivatives that are useful in real life problems. I'll put bunny quotes around real life problems, but there are some really significant problems out there that actually use rates of change to make discernible information. Anyway, so that's just how we do it. And we have a whole bunch of different ways to do that. So on the back side of this particular set of notes, let's talk about a few extra things. So right here, I'm asking you to take f triple prime. In other words, the third derivative. So I'm going to write y prime. Then I'm going to find y double, and then I'm going to have y triple. There is no way that you can go straight from the original all the way down. You just have to do it one at a time to get there. But power rule says 6 times 2 is 12, divided by 3 is 4. 4 times 2 is 8, and 5. So I found y prime, and you'll notice it went from a 6th degree down to a 5th. The 4th went down to the 3rd. If you go to double prime, we're going to take the derivative of this, which is 20, 5 times 4, x to the 4th, 20x squared, and then one more, and we are done. That's all there is to it. That is y triple prime. And then over here, this says, let's go ahead and take the second derivative of x cosine x. So the first thing I would do is, if we wanted to find the first derivative, I'm going to do f prime g plus g prime f. So I would prefer to write that as cosine x minus x sine x. Okay, so f prime is that first derivative, and notice that I didn't really like writing it with this x on the end. It feels a little dangerous because that x is not part of that sign. That's exterior to that. That's not one of the angles. So if I wanted to look at f double prime, or d squared y dx squared, remember that's another notation, then we would get the following. So the derivative of the cosine is negative sine, okay? So keep in mind that a derivative is a limit, and so if you take the derivative of all of this stuff, I could take the derivative of them separately. And I'm going to go ahead and make a parentheses because I'm going to be very careful here, and I'm going to do f prime g plus g prime f. So the derivative of, so again, the negative I'm sitting in front, the derivative of the first times the second plus the derivative of the second portion times the first. Now, again, like I said, I'm not a super big fan of this kind of notation and writing it that way, but I'm just kind of trying to follow the rules. So I have a negative sign and another negative sign. So it looks like I have negative 2 sine x. And then I have a negative here, so it'd be minus x cosine x. Would be f double prime of x, also known as d squared y dx squared. Okay, so hopefully that's pretty good. And then we're going to do one problem using a table. Oh my, that looks a little bit scary. I will tell you, AP writers, as well as your teacher, really like those for final exams and things like that. So what we're going to try to find is this value given some of these pieces. So we're going to start right here by finding out what h prime is in general, which again is low, d high, minus high, d low, over the square of what's below. So I just literally just wrote down all of that stuff, right? So if that's true and I wanted to find h prime of 0, then that would be g of 0, f prime of 0, f of 0, g prime of 0, all over g of 0 squared. Boy, that's a lot of stuff. And now what we need to do is we need to go back into this original thing. There we go. I wanted to see it. And we're just going to take one piece at a time. So I got a number here, 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 and here squared. Okay, so g of 0. So g of 0 is 5. F prime of 0 is negative 3. F of 0 is 2. G prime of 0 is negative 1. And G of 0 is 5. So by putting all that together, I have a negative 15. This looks like there's a double negative there. So plus 2 over 25. So it looks like I got negative 13/25. And that would be all we can do. Now, I will say this next problem is, well, it's going to be a little bit icky because we really haven't dealt too much with what happens when you have 3 pieces. But what's going to happen is it's really an extension of what we did, because what's going to happen is you're going to have the 3 pieces right here. And so if we were to take the derivative of all 3, you're going to do the derivative of the first times the second ones. So h prime would be the derivative of the first times the other 2. Plus the derivative of the second times the other 2. Plus the derivative of the third times the other 2. Now, that may seem like I'm not quite doing what I did, but keep in mind, I could group this as the first times the second, right? And the derivative of the first would be 1 times the second, plus the derivative of the second times the first, but the derivative of the second would be f prime g plus g prime f. And if you follow that along, I believe we have what I have, because I have one fg here. I have an x with an f prime g here, and I have an x with a g prime f there. So that's kind of how I do it. So anyway, if we're going to find h prime of negative 1, that means we're going to have 1. Of course, f of negative 1 is right here. It's 3. G of negative 1 is negative 2. Got all that. Plus f prime of negative 1, which is 4. X was negative 1 because we're replacing x with negative 1. And g of negative 1 is negative 2. And then we get to the last one. G prime of negative 1 is 2. X, of course, was negative 1. And our last piece, f of -1 is 3, and it's turned into a pretty simple evaluation problem. I got -6 here. I got +8 here from this chunk, and this last chunk is another -6. So grand total of -4. I think we finished. I think that is plenty, plenty, plenty. Okay, hopefully that was helpful. I will see you back in class. All right, bye-bye.